Hello everyone, I am Aditya and in this video we are going to look at the breadth first search program. So how do we do that? So we'll continue with our data structure. Over here I'll create space for breadth first search, BFS. So now I'll define a function BFS and pass the argument as self and start. Start will be the vertex through which I want to start the breadth first search with. First of all, I'll define a set which will be visited. So visited is equal to set, just like the case with depth first search. We will use this to track the nodes that we have visited. Also, I'll define result as a list that will store the breadth first search result. And the new thing that I'm going to introduce is queue. So queue is nothing but a data structure that follows first in, first out, and in Python we can represent it using the simple list, that is array. So I have defined a list and I have stored the first element as start in it. So we are going to use it to perform the breadth first search. So while the queue is not empty, so we write that using while the length of queue is not is equal to 0. I want the loop to continue while this case is true. So what I want to do is, first of all, I want to pop the first element in the queue, first element, first out. So pop 0, the element at 0th index, and it will be popped, stored in vertex. And if this vertex is already in the visited, I want to continue, that is continue with the loop. And if not, I want to add it to the visited. So now this vertex is visited and not just visited. This I want to add this vertex to the result as well, because we have traversed it, we are traversing it. So I want to add it in order append it to the result. And now I'm going to iterate over the neighbors of this vertex. To do that, we have the following line of code for neighbors in self dot adjacency list vertex. Uh, First of all, inside this loop, I want to ensure that this neighbor is not in visited. So if neighbor not in visited, so if this is the first encounter, we want to add this neighbor to the queue list or the queue data structure, which is in this case just a list. So I'm going to queue dot append the neighbor if that neighbor is not visited yet. If it is, I'm just going to ignore it. Now I'm going to get out of this loop, out of the while loop, and I'm going to finally return the result. So now let's test the output for this and compare it with the depth first search. So to make it more readable, what I'm going to do is I'm going to add some string over here, that is depth first search followed by arrow and then the list as output. Now I want to do the same for breadth first search. So I'll again print, and this time I'll pass the string as BFS followed by arrow, comma. I'm going to call the BFS function of the G object, so g.bfs, and I'm going to pass A as the start vertex. So let's run the program and see what is happening. So clearly we have some difference in the output of depth first search and breadth first search. Especially we can observe that it is ABCD and it's not the case in depth first search. So what is happening over here? Let's So how do we analyze how the output of BFS came on the screen? So to do that, we started with the node A. We popped it out of the queue. We iterated over its neighbors, which are B and C. We appended B and C to the queue, and then we came out of the loop of the neighbor loop because B and C are the only neighbors. Then we popped out the first element that we append the element on the front end, which is now B. So we popped out B and then we iterate over the neighbors of B. So the neighbors of B are A and D. A is already visited, so we append only D to the queue. Now the queue has C and D in it, and now we will pop out the first element from the queue. So we pop out C, and now we are going to iterate over the neighbors of C and add it to Q. So you get the idea how we are going to proceed, right? So I recommend that you take a pen paper, you write the queue, you go in the order of the code, you pen, pop, and see how the code is working, and you'll get the idea how visited is, ensuring that we are not uh, revisiting any vertex more than once, and how the breadth first search is working overall. So with that, we have completed the basic understanding of graph data structure. We understand what graph is, we know how to traverse, and next up we will be practicing some questions, and as we practice some questions we will also come across some new theories or concepts that are regarding graph. So see you there. Bye bye.